basically a system is two or more equations, and you're looking for when all of the equations are true. So what solutions make them both true? If you're thinking about lines, then it's possible when you graph two lines that they meet. So when we're looking for that solution, if they meet somewhere, that's called consistent. The equations are independent. So it's two different lines, and they meet at a point. So something like that. You're looking for that point where they cross. It's sometimes we might have infinite solutions. So that happens when you graph one line, but then you go to graph the other one and it's the same thing. So basically I gave you two equations for the same line. So that's consistent because we got an answer, but they are dependent because they are the same. And if it has no solution, we call it inconsistent. How would you get no solution? Right. So you might want to write down that terminology. I know you did systems in Algebra 1 and Algebra 2. I don't know that you've necessarily talked about independent and dependent, consistent and inconsistent. So basically, if you get a solution that's consistent, if you don't, they're inconsistent. If it is the same line, that's dependent. If they're different lines, it is independent. So let's look at a problem. When you solve these before, you really learned several different methods. You can do substitution, you can do elimination, you also talked about graphing. I don't use graphing very much because it's not very accurate. If they don't meet at integer values, it's really hard to know the exact point. Also, if when you're drawing your lines, you're just slightly off, you get the wrong point. So I'm not really going to even try that method. I want to do the things that are going to lead us to a correct answer. So do you remember what substitution was?
Don't you get a variable by itself?
Mm-hmm. Pick one of the equations, one of the variables, and get it by itself. Doesn't matter which one. So what do you want to solve for? X in the first or second? Okay. So if I want to get x by itself, I subtract my y. So x is 8 minus y. Then you sub that into the second one. So my x, 8 minus y equals 4. Okay, subtract our 8. Divide. And y is positive 2. Then once you have y, you come back up here. X is 8 minus y. So 8 minus 2 is 6. And then because this is an ordered pair that we are finding on a line, I would like for you to write it as an ordered pair. Is this consistent or inconsistent? Consistent. We got an answer. I didn't ask for these terms, but it's good to practice them. Is it independent or dependent? Good. All right. Let's look at another one. What if I give you this one? Is there an easiest option here?
Top one,
Yeah.
solve for y.
Solve for y in the top. Not that you have to do it that way, but it avoids fractions. We subtract our 2x. Y is 5 minus 2x. So then we're going to plug that into the bottom. So we have negative 4x plus 6 times 5 minus 2x equals negative 2. 16x. Subtract the 30. Divide, so x is positive 2. By the way, do these have to work out to be nice answers? No. Alright, and then once I have x, I can plug it back in for y. So y is 5 minus 2 times x. So 5 minus 2 times 2 is 4. So y is 1. So the answer is 2. Were you okay with substitution? Let's review elimination. What's the goal of elimination?
Cancel a variable out.
Yes, we want to be able to add the equations together and get something to cancel. In order for a variable to cancel, we have to have opposite coefficients, so like a positive 5 and a negative 5. So to get that, we might have to end up multiplying one or both equations by something. If I look, first you just have to pick which variable do you want to cancel. X. Okay, how would I do that?
Multiply the top one by 2.
So that gives me so now we can add these together. Those drop. So we get 8y equals 22. Divide by 8. So y is 11 over 4. So then how do we get x? Plug it into one of these equations. So I'll just go with the first one. Okay, so if we subtract over the 11 fourths, so 5, so 20 over 4 minus 11 over 4, divide by 2, we get 9 over 8. How can you check yourself if you're not sure on any of these? You could look at that, the graph on the calculator. What other options do we have? Yeah, you can plug it back in. You would need to check both equations to make sure. But you can plug the x and the y in for both equations and verify it that way as well. Let's look at this one. What would we do?
Multiply the top by 2.
Positive or negative?
Negative.
So when I add those together, my x's cancel and my y's cancel. So that leaves me with 0 equals negative 10 plus 8 is negative 2. What does that mean? No solution. What do we call it when there's no solution? Those terms at the beginning? Inconsistent. Most of the problems that I'm going to give you, I'll say if you identify any inconsistent systems. So the answer is the no solution, and it's classified as inconsistent. So what does that mean about these two lines? Right, they're parallel. They never touch each other. Okay, good. Okay, let's try this one. Any thoughts what to multiply by? Let me ask this. Which variable do you want to cancel? It's toss up. Pick a letter. Say I want to get rid of x. What would you have to multiply x by to get rid of the fraction? 3. And then to get a 6, you'd have to multiply it by a 6. So 3 times 6 is 18. So 18 times 1/3 is 6. 18 times 1 over 6 is 3. 18 times 2/3 is 12. So when I add, those cancel, so we get 0 equals 0. What does that mean? Infinite solutions. Now, we are going to be a little more specific about what the solutions are. Instead of just saying there are infinite solutions. Is it every single ordered pair out there that exists? It's any ordered pair that is on these lines, right? So our directions will say, like for an infinite system, write your solution with either x or y arbitrary. So if I said to write your solution with y arbitrary, that means we keep the y. So my y value is just y. And we have to figure out an expression for x based off these equations. So essentially we're going to solve for x in one of the equations. Probably the easiest in the bottom one. So if I were trying to get x by itself, I would add my 3y. Divide everything by -6. So x is 2 minus 1/2 y. So it's a way of describing the ordered pairs that fit on the line. It's not just any random ordered pair, it's only the ordered pairs that are on the line. If I said to do it with x arbitrary, means we keep the x and we have to solve for y. And so if I solve for y in my equation, I could add my 6x, divide by -3. So I'll always ask you to do one or the other, but you have to be able to give me those ordered pairs. You guys understand how I got those? Why don't you guys try one? When we're talking about lines, we've seen that either they meet at one point, they don't meet at all, or they're the same line. It's every point on the line. But if I'm talking about nonlinear, you might have multiple meeting points depending on what it is. Like if I talked about a parabola and a line, and those could meet twice, or I could have a parabola and a line that only meet once, or I could have them that meet never. Or if I'm talking about a circle and a parabola, I could get up to 4 different points. So when we have things that are not lines, they can meet multiple times. Our strategies are similar. We still want to do substitution and elimination, but it's not quite as straightforward. It's usually a combination of the two that we would have to involve. So if I looked at this one, essentially we have basically 3 variables. We have an x squared, we have an x, and we have a y. What's kind of the odd man out, the one that really doesn't fit in? The x squared is the square. What does that do to our problem? What kind of graph is it if it has an x squared? A parabola. So we know because of that x squared, we are probably going to get multiple intersection points. Now, if I want to solve a quadratic, I could solve a quadratic equation if it had both an x squared and an x in it, right? So let's try to eliminate the y. And it's actually set up pretty easily for us to do that. If we add these equations together, negative and positive y cancel. So we have x squared plus x equals 2. So it's a quadratic, so we subtract over the 2. Multiply to negative 2 and add to positive 1. So if we set those to 0, we get negative 2, positive 1. That's giving us basically two different ordered pairs. We need to find the y for each of them. So we can plug into either equation. I might just go with the second one. So if I put that in, I'd have negative 2 plus y equals negative 2. Add that over and we get y equals 0. So negative 2, 0 is a point. I plug in a 1. 1 plus y equals negative 2, so y is negative 3. Is that one okay? Let's look at this problem. What are your thoughts? Y squared drops. So x squared equals 4. Square root plus or minus. So x can be positive or negative 2. If x is positive 2, so square root plus or minus 0 is the same, so we get 0. So 2, 0 is a point. If x is negative 2, what are we going to get? Same thing. Just as a side note, if, let's say we plugged in 2 and we got like y squared equals 9. When you do the square root, you get y equals plus or minus 3. So that's actually 2 points. 2 positive 3 and 2 negative 3. So that can happen. Okay, to that point. Then, if I plug that in, if I put in y equals 3, so 3 squared is 9. Square root of negative 4, that's plus or minus 2i. So that means x could be positive 2i and y could be positive 3, or x could be negative 2i and y could be positive 3. If I put in a negative 3, negative 3 squared is also 9. So we get the same thing. So we could have positive 2i, negative 3, or negative 2i, negative 3. So we get 4 order pairs of 10. Any questions for me? There is a handout posted on Google Classroom. It's your assignment, and you've got the rest of the hour to work on that and ask questions if you need to.